Hey, what's up everyone? DJ Sterf here, and this is not going to be an exciting video for most, but I'm going to go through some data points. I collected 9,365 data points with my automation. If you want to see the process I went through with all of that and how I got rid of DD every time and just focused on MeBird and Rockstar Foxy, yeah, you can go to the last video, the 800 trials of Rockstar Foxy. Well, I have 9,365 possible showings of MeBird, and then if you click on MeBird, what happens after that point, whether you get jump scared or whether you get that menu, you know, the one where you get plus 1% power option or soundproof or 60 degrees or plus 10 coins. Okay, so you see here AI is directly proportional to the jump scare percentage. So AI 20, it's about 2 and 3, but it's not quite exact. So I'm thinking this is actually a little bit different. Someone on the last video suggested that it might be AI over 30, and that's actually really close, I think. But the problem is AI 0, you do get jump scared some, and I was thinking it might be 95% of the time you get a friendly encounter, so 5% jump scare at AI 0, but it's closer to 3, and I think it's actually probably this. Expected for AI plus 1 divided by 30. So if I do this plus 1 divided by 30, that's what I would expect, and I'm going to fill right here. You see some of these line up really, really well. Let's show an example here. AI 0. I would expect 3.33%, but instead I'm getting 3.10%. 6.67%, I'm getting 6.83%. 10%, I'm getting 10.07%. And the more values that I have in my data set, the better, because that's going to be more representative. And the problem with higher AI levels is MeBird shows up less. So 23% of the time on this data set out of 1,000, MeBird actually showed up. Well, I kind of wanted more data points, but I only had 234 on this, despite having run this for 1,000 different minutes. And yeah, it's just, you have better possibility of getting a really, really representative sample with low AI because MeBird shows up more often, and that gives you a chance of getting a jump scare or a friendly encounter. It's very rare you see 1,094 of the encounters at AI 0 were friendly and 35 were jump scare, but it does happen, and it does happen at about the rate of AI plus 1, all in parentheses, over 30. You can also just do AI divided by 30 and then add 1/30th to that result, but I mean, that's just, yeah, that's distribution there. All right, so what else do I want to track? I want to get the average difficulty, average AI weighting. I just do this. We're going to call it AI weighting, and I'll put the averages at the end. So we're just going to do number. All right, average difficulty, 6.85. Yep, that's actually correct. Okay. Yeah, because you have more showings at a lower AI. So I also want to get the jump scare percentage weighting. Okay, so what I want to do here is I want to take the jump scare percentage times the number of jump scares times the AI, and then I'm going to fill this right, and it's going to be a number. It's not going to be a percentage. Just want a number, and I need to divide this by that. So 22 point. This is a percent. 22.51% average. Is that right? So the average AI is 6.85. The average jump scare percentage is 22.51%. So what is 6.85 plus 1 divided by 30? 26. Huh. That's interesting. Yeah, some of these values are a little bit lower than I would have expected. It'd be interesting to plot a regression line through this. Let's do a difference. Difference between difference actual versus expected equals this minus that. I need this as a percentage. Okay, I'm gonna fill right. It really seems to go off in this area especially. I might just need more data collection, but the average that it's off is negative 2.50%. Just as an unweighted average. Yeah, so it's seeming to be under AI plus 1 divided by 30. Well, it seems to be pretty linear. Sure, one. Oops, I need one above. All right, difference versus next AI. So, actually, let's do it the other way around. So C8 minus B8. What's the average? So I don't need a weighted on this one. I just want an average difference, 3.11%. Could it be like AI? Let's see. So this is this. Is it 32? It might be AI plus 1 over 32. I don't know why it would be 32, but let's try it. $313, and then hold on. Let's do it over here, and then wow! Look at this. That's still not quite perfect, but that's getting close. That's getting close. It might be AI plus 1 over 32. I don't know why it would be 32. Why does Scott like 32 and 33 so much? Like, you notice all the version numbers and all that in the games? Yeah. 1.031, 1.032, 1.132. I did force him beyond 3.2 on Freddy in Space 2, so you might notice that version number is actually more than that. Okay, that might be it. Alright, so I bet that's pretty darn close. That might actually be it. I don't know. It's kind of crazy how close some of these are. That's within 1/4%, and that's within a 30th of a percent, basically. 300ths, a 33rd of a percent. Okay, so the show percentage, it's going to be a little bit different. You have the point at the axis here, 72.37%. I don't know if that's 3 out of 4 or whether that's some other funky number here. 72.37. What is 22 over 32? That's not it. 24 divided by 32 would be 75%. What is 23 out of 32? That's pretty close. That's really close. Okay, so what is 22 over 32? That's really close. So you're looking at, hold on, AI minus 22 divided by 32. I don't. I mean that's probably totally wrong, but no, not. What am I thinking? 22 minus AI. 22 minus AI divided by 32. That's not it. That's not it. Okay. There could just be a percentage difference. Okay, so it's not 22 minus AI over 32. It's not. There's got to be something else to the formula here, and where it hits the axis. I mean, you could plot this 23 over 32 minus 1,000 divided by the AI. Right? No, that's not it. That's not even close. Okay, so minus. No. Divided by 20. So I want what? 1,000, but this is gonna have to be divided by 100. It's 10. Yeah. That's not it. Oh, that was stupid. You're not going to divide that by the AI. You have to have that as a... You can't divide by 0 on this because AI can be 0. So expected for 22 minus AI divided by 32. Nah, that's not it. I mean, that would be pretty close toward the end there. You see it kind of catches up. So you sort of, it kind of catches up. It's not all the way there. 25 minus AI divided by 32. 25. That's still not it. What do I need this to be? About 8, right? So let's say it's 7. Let's say it's 7 out of 30. So 27 minus 8 over 32. 27. That's pretty close. What about over here? Ah, it's too much. It goes over to 84% there. So that can't be it. 320. No, that's not even close. That's too flat. It's too flat. So what are we at now? 183. All right. So expected for 183 minus AI times 5 divided by 320. Yeah, that's it. That's it right there. That's percentage. Yeah, that's not it. That's not it. All right, what is 27 minus AI divided by 32? I got rid of my font and my centering and my percentage and my formatting. Here you go. That's too much. It's gonna be halfway between this. But let's actually create a chart. Okay, I actually maybe a scatter plot. Trend line, yes. Yes, look at that. Okay. Oh, look at that. Look at that. 0.962 R squared value. Wow, that is extreme correlation. But I'm not surprised. Line color. Perp. Actually, let's make it closer to Rockstar Foxy color. All right, and then yar. Label, use equation. Yes, look at that. Yeah, that is what I want. Yes. Oh my goodness. So it's negative 0.0239x plus 0.716. And that's, of course, it's hitting the axis pretty near this show percentage here. Let's see. Let's do a better insert row here. Expected for... What is that? What is that? What is 1 over 42? 238? What is this? 239. 1 over 41? No. It might be 42. So that's the difference between the AI values for the show percentage. So what am I trying to do here? The difference is you're going to have y minus AI divided by 42. So what is y? What is y here? So AI over 42, so that's minus 0. So you have to figure out what this is right here. What is this equivalent to? So if you have 30 divided by 42, 31 divided by 42 maybe. 30 divided by 42. So what is this? 30 divided by 42 minus AI divided by 42. 30 divided by 42 minus that divided by 42. That's pretty darn close. That is really close on a lot of those points. It's not exact for sure. That's really close. Okay, there's got to be some kind of difference here. I mean, the other thing is too, like the 0 could be 75 and 20 could be 25%. So if I did expected at 25% and 75%, that would be basically I mean, it's 3 out of 4 3 out of 4 minus 50%, so 0.5 divided by AI over 20. So let's see, divided by this over 20, that'll be 25, and then that should go up to 75. I did that wrong. I did that wrong. Okay, let's try that again. This divided by 20. So if it were 10, it'd be 50. You can multiply it. There it is. Yep. Ah, there we go. All right. That's not too far off on some of those points too. It ends up a little bit off for sure. So we really need more data points to get a full scope of this, or if Scott just emails me with the actual answer, that might be kind of cool. What else? But that's pretty close with this data set, and if you look at the regression line here, R squared is 0.962. That's pretty close, but the difference there per tick basically is 0.0239, and then you have 0.716 where it's going to hit the axis. So it's estimating based on this that 71.6% of the time you're going to have a showing of MeBird at AI 0, and then it's going to go different from there by about 1 out of 42 every tick of increase of AI. So that's a lot of I got to make a note here, so insert one below. Oops, that's not it. Insert row. Yes. These are attempts at fitting the data collected. See projections and charts in this spreadsheet. Okay, so left justify this, and that's a lot of stuff in here. I don't know, you're not going to get an exact value here, but that at least gives you a pretty nice estimation. I mean, anyway, so I got to find out what the exact is. I was thinking it was going to be AI plus 1 over 30, but I think it's actually really close to AI plus 1 over 32. The only way to tell for sure is looking at the event editor for sure. And so actually what's programmed in, or the other way is get infinity data points, which cannot happen. That's why you have statistics. You have a representative sample, but this gets it really, really close. So anyway, I can make a chart for the jump scare percentage as well. Okay, now let's create a chart for this one. So insert chart, and I want a scatter plot, and then I want that's a really nice R squared. Okay, so I would expect with more trials of, say, AI 12 and AI 9, I would probably get closer results, better distribution. But I don't know. I don't want to cherry pick stats here. But I do need more data points for a clean line. But that's super close. Oh my goodness. That's super close. So anyway, all right, that's about it. I guess I'll keep it here. This is in the 50-20 strategy, power usage, odds, etc. spreadsheet. Yeah, that's about it. Yeah, that's high correlation, lots of data points collected, and yeah. Okay, that's it. So thanks for watching, everyone. Peace. God bless you. Have a great day. And if you want to make a measured, calculated risk, this gives you a very good estimate of the odds of getting jump scared and having B-Bird show up. So anyway, hope this helps. All right, peace. Check your next video. Wow, 315, 316. Let's see what I can pull here. Just do crystals. Woo! 318, 370. 318, 370. Oh my goodness, that is nasty. That is disgusting. Wow. Okay, so, yeah, that's a new record.